Alright, on this video we're going to discuss the installation of the tools from Segger. Just to start looking at the IDE that we're going to use for this course. Okay, so remember that in the Segger Tools we have three things. One was the ST-Link reflash utility that was just a simple portable tool to convert from ST-Link to J-Link that we showed you in the previous video. And then we have the actual Segger Embedded Studio integrated development environment, as well as the J-Link software, which is necessary for the J-Link interface. Okay, so we need to install both. So I would say maybe let's download and install the J-Link software first. We have to agree with this terms and then say download software. And I believe I have mine already downloaded here. So I'm going to execute it and install it. Okay. Now, here's some options that you have, and this is important to be discussed. So if you're installing this at home, well, you first have an option of updating the existing installation, and this software sometimes get updated, and you could override the current installation. I believe I uninstalled mine already, so it should be a clean installation, new instance. Also, you can leave the rest as default, and this is important actually. You can install for all users or install for this user only. In this case, will be installed into your personal folder. Now, if you're installing this at home, at your personal computer, for sure I would say install for all users, right? But if you're installing it in a computer that has limited access, that you have limited access to, let's say a school computer, for example, then you want to do the installation as a user only, because then you won't be able to write into this folder. Okay, in this case, since I have full access for this computer, I'm going to install for all users. And yeah, I just leave everything else as default, and that's going to copy and install everything. As you can see, this is very fast, well, depending on the computer that you have. Three applications found that can be updated. Oh, I guess, yeah, it's going to update those installations that I have. I would say yes, although that's not relevant. You may not get those messages. So now let's go to the installation of Segger Embedded Studio. Again, we click on this one here. It will prompt us to a different similar page, right? And mine, I have it already downloaded here, and it's the version 8.24. This also gets updated very often, so chances are that in the lab computers we have an older version, or when you are working you will have a newer version, or when you start actually working with this micro, there will be already a newer version than this one. But I guess that's not too big of a deal. You accept the agreement and install. I believe this one needs admin rights to be installed, so you won't be able to install this in the lab, but I believe this is already installed in the lab, so it might be an older version, but it's already installed there, so nothing to worry about that. And leave everything else as default and just install a shortcut, and this should take some time, longer than the other installation. So we're gonna probably pause the video, the recording, and then resume once it's done. Okay, so installation is already done, and this is going to start Segger Embedded Studio by default right away. And this is the software that you see here. Now, since these I had it already installed before, it has some history of projects open, but normally you will have a default project that opens when you first open this IDE. Okay, and there are certain things that we want to look into here, but first we need to go to install certain packages in case they are not installed yet. So I just reset all the user settings, so I could probably emulate what you're going to see the best way. So one of the things I want to do is to first check for the packages. So I go to Tools, Packages, Package Manager, and I look for ST because our microcontroller, our development board, and micro are from ST. So we need to make sure that the STM32G0, which is the one that we're going to be using, is actually installed. Okay, so STM32G0XX CPU support package. So we make sure we click on this one and we say we toggle it so it gets installed, and we just click on next, and that is going to install the package for this microcontroller. Okay, so before we can use it, we have to do that. So and this is just the browser. We can swap to this tab from here back and forth, or we can close it whenever we're seeing this. Another thing that we want to do is go to View, that I find useful, and then we go toolbars, and we set up the debug toolbar so we can actually debug a project and run it directly from here. And the other thing we want to do before we even start using this is go to Tools, and then Options, and then we go to Text Editor, and we look at the Programmer Assistance, and we look at the Code Completion Suggestions Selection key. So right now it's set up to enter to the return key. Okay, so that is kind of unnatural for what we used to do with Visual Studio. So whenever we have code completion and we want to complete it, we press tab, right? So we want to change that to actually be activated with tab. So that's probably going to be better. Okay, so this is now the previous settings that we needed to do in order to before we start working with this IDE. Now, if you first install this, most likely it's going to have like a Hello World project open by default. I don't have that here because I don't know, I wasn't able to bring it back. But how you basically start a new project with this development board that we're going to be using, we just basically go first File, and we say New Project. And in this particular case, so what I'm going to do is, so I'm going to search for the ST packages, and I'm going to select a C, C++ executable for ST Microelectronics STM32G0XX. Okay, and where I'm going to locate this, I have already created a repository here. Let me just find it so I can keep things organized. And this is 2025 fall video demos, intro demos. So I'm going to place it in there, and this is just going to be called intro demo 1. So, and this, just like in Visual Studio, we can have one solution, multiple projects inside. So for simplicity here, I think we're going to keep it one solution, one project. Now the defaults here, the target processor, as you can see, is the wrong processor. It picks that one by default. So we need to make sure we select STM32G031 K8, which is our actual micro. Okay, well, it's actually a K8T, I believe it is. Let me just check the schematics here to make sure which one is exactly. Is the KAT6, so you'll be the KAT, okay? So that is the actual target, that's important. So the compiler, we use Segger, we can use also GCC, but the Segger compiler is better. So the other configuration can be left at as default. So we probably want to have support for float printf, although we're not really going to be doing any of that yet. We'll explain what is that for. Maybe for scanf as well. So that is not relevant right now. So what else do we need to save here? Nothing else. Next. So that's going to bring up all those files. And we're getting this message, and we normally get this message at the beginning when we first open Segger Embedded Studio all the time. And this is basically saying that if we're using Segger Embedded Studio for non-commercial or educational purposes, we can use it for free, no issues. In case you're not using it within that scope, then you need to get a license. In our case, we're good, so we just accept and have this project here, and this should have a main file. See, and now we have created this. The system creates automatically this sample project for you. Okay, that is actually printing something on the console. It's printing actually 100 times hello world, and then it's incrementing a counter for it, which is our int variable here. Now we have to explain how can this actually happen, because printf is a function that is equivalent to a write line in C#, right? But that is meant to be used on a desktop computer where you have an actual input-output system, like a screen. In this case, we don't have anything. However, this still works, so the question is why it works, but we will explain that. So I don't know why my debug window went away. So let me see. Toolbars, debug. Okay. And so we have a solution, and inside we have a project. If we right click on the project in the options, we can configure the options for the project. And there are many things that can be configured here. We did some of that at the beginning. I'm not really going to go over all of them in this video, but for example, the language standard is set by default to C99 or GNU 99, so we can actually change the language standard here. So we will talk about that later, where the differences between the standards, and then you will see that you can do certain things with the newer C standards, like an inline for loop declaration, for example, when you declare the variable inside the for loop header. So okay, so but that I'll leave it as default for now. So the important thing here is the debugger. So the connection, as you can see, is set to J-Link. That is the default. You can also use GDB server or ST-Link, and this is related to what we were talking before about ST-Link, J-Link. So if you are using a development board that is set to ST-Link, then you need to set this as ST-Link. But the default is J-Link. And since I converted my development board to J-Link, there's nothing really to be done here, which is very convenient. Okay, and the interface, as you can see, is ARM SWD. We did talk about that. It's not full JTAG, it's not CJTAG, it's SWD. So all the defaults are good here. So we don't really have to worry about anything else. Now there's also a way here of setting this debug interface to simulator. So you will do this whenever you don't have a board and you just want to test some of your C code and the IDE and Virtual Console without having to connect to a target. In this particular case, since this is set up to J-Link, is going to expect an actual target, meaning that it's going to expect to connect to a microcontroller like I have here, this development board, through the USB cable. Okay, so if I don't have it connected, then this is going to give me an error, in which case I'll have to change this to simulator if I want to run any code without having to connect to a target. Okay, so even though this code is not really doing anything in the microcontroller, it's just printing somewhere hello world. Let's see where that somewhere is going to go. So let's run this. Sometimes the first time you run this, it takes a while to build for some reason. That just happens the first time. I think it's just a bit of a bug. Yeah. So then you get this message, hopefully only once you check, do not show this message again. This is just a license agreement for using J-Link. You accept it and you run the code. So at this point you're running, not yet because you haven't pressed run. But yeah, so continue execution. So basically the code is starting to run and it's jumping to the first line here of where the int main is. And if we run this, it's going to run the code and we see that we look at all these hello worlds happening here. But nothing really happened on the microcontroller because we're not yet setting anything on the microcontroller. So what is this hello world doing then? So I did say that the printf, it's a way of using the input output to display something on the console, just like your console.write line. However, in here, technically, there's no console because this is not a Windows desktop application, right? It's not a console application. It's an application that is meant to run on this microcontroller. Remember that we said that we needed to build this code, convert it into a binary, and then eventually get sent to the micro and stored in the flash memory. So how is this happening? Well, this IDE is nice in the sense that it has this virtual console that you can actually do things here for testing, like sending hello world, for example, to this virtual console, but it's just virtual and it's meant to just run when you have this IDE open. So it actually does not do anything to the microcontroller itself, okay? Just to be clear. But even though this code is not doing anything in the microcontroller, we are still connecting to the target, which is why the J-Link window popped up and it was expecting, like I said, a target. So what I'm going to do now is just turn off that USB port so the actual board gets disconnected. And I'm going to try to run this again. And now I get this error because it's telling me that it cannot really find any probe, like any J-Link connected via USB, because actually the board is off. Okay, so no target. So whenever you get that message, means that there's no actual target connected to the computer. So what we can do in this case, let's say that for some reason we don't have the board and we want to test this simple code that just says hello world. So then we can change in the debug window. So again, we go to the project settings, right click options, we go to the debug section, and in the debugger, in the target connection, we can change this to simulator. So, and then if we change it to simulator, now this thing is not going to be expecting any target connected, so I can just run it with no issues. See, but the J-Link thing didn't pop up because now this is just running on the actual virtual console, nothing else. Okay, so hopefully that is clear. So in the following videos, we're going to discuss more detail because now we need to start digging into the C language, the syntax, and the microcontroller registers and all that kind of stuff. So for now, this was just to be able to start a new project and to get familiarized a little bit with the IDE. There are some other things that you can do here. For example, setting the options. In the text editor, you can change the theme here. I'm not exactly sure what, color themes here. So you can change the theme. So it's crosswork standards right now, but you can change it to a dark mode or dark modern, for example. See, it shows here the actual, for the ones that like the dark background. So that may work for you, or you can change it to a different what other dark modern? There's also a dark, which is not really that dark. Yeah, but you can definitely play with these settings and get familiarized with the IDE. That's the idea at this point in the course.